Okay, so I think what we want to do is let's review this troubleshooter, okay? I know a lot of you got it right on, so that's good. But just in case you didn't get it, we'll walk through it. So let's see here. Now, if you've noticed, this is the same topology, right? So we should be kind of getting familiar with our tech building, our sales VLAN, our customer service VLAN, and the library. So let me pull up the directions here, because when I pulled this up and I read it, I noticed something right off the bat. Okay, I noticed something right away. So let's see, library network is able to sometimes get through to the sales VLAN when it should be completely blocked. So basically, the personnel in the library, right, they should not be able to get over here to the sales network. Now, did anybody have trouble figuring out which one was the sales network? So if you remember, we did that last week. There's a couple of different ways you can do it. So I did show VLAN brief, okay? And I saw right here, oh, VLAN 20, it's my sales network, and that's off of F020. So I could just see it right there. Okay, now there's other ways too. I believe we probably could have done a show IP interface brief from there, right? And here I can also see the 20, but I could do a show run and just check out my interface descriptions, right? So I can, oh, and see, here's my DHCP information. So if you dig around a little bit, it's pretty easy actually to figure out which one is our VLAN 20, okay? Okay, so on here, under the scenario, what, if anything, kind of clued you in as to what could be going on? There's one particular word that just was screaming at me. Right, Aaron. Right, Luis. Sometimes, the word sometimes. Okay. And I'm like, well, that's weird. I mean, why would it be sometimes and not other times? So why could it be? So if I'm right here, right, and then I get here, right, and remember, we're trying to block the PC3 basically from getting to PC2. So if I'm a packet and I'm, I'm moving along here, what next? What could explain the sometimes? What could explain the sometimes? So
It could be like exiting the interface from like serial interface 00 and like be blocked in that area, but then it just finds another way to through the serial interface 001 on library to
right,
basically go around it.
right. So as soon as I saw that, sometimes I'm like, okay, what's happening? So remember, these networks are going to load balance, right? So they're going to load balance just to kind of spread out the load. So sometimes they'll send a ping one way, sometimes they'll send a ping another way. So right off the bat, what that told me is that I have inefficient placement of my access control list. Now, I still really didn't know where the access control list was placed, because in the scenario that we're talking about, we could have placed an access control list ineffectively right here. I could have placed it right here. I could even have placed it right here. That would stop it. I could have placed it right here, right? Or I could have placed it right here or right here. So putting one access control list in either of these places could cause the problem that we had. Because no matter what, if we just put one access control list, there's always another way around, right? Oh, that didn't work. Let me try this way. That one didn't work. Let me try this way. Okay, so that's the first thing I knew. I'm like, okay, something's going on here. Now, the other thing that we couldn't tell by looking at this is whether or not we had a standard access control list or an extended access control list, okay? So now, if I have an extended access control list, where would be the best place to put it? If I had an extended access control list, where might I have put it? Right, closest to the source. So the first thing I did is I just came in here to the source and I did a show IP access list, okay, just to see if I saw anything, and I didn't. Now, I will tell you, access lists can be a little squirrely. So I actually just went ahead and I did a whole show run. So I'm like, okay, there's no access control list here. And then the other thing I did is I actually just looked at the serial interfaces to make sure I didn't see any ins or outs, just ruling out all the possibilities. So I was pretty sure that I probably didn't have an extended access control list because I didn't see anything close on the library router, which would be close to the source. So then my next assumption was that, well, maybe I've got a standard access control list. So where would I put a standard access control list? Yeah, as close to the destination as possible. So yeah, on the tech building. So the next thing I did is I went over here and I did a show IP access. Oops, what am I doing? Show IP access list. Oh, okay. So I can see here I have a deny statement, right? And it's for the library and everything else is being permitted. So I'm like, okay, well, now I need to see where this is at because that might actually be the right access control list statement, but maybe it's just placed wrong, right? Because our assumption is it's on one of these serial interfaces. So now I'm just going to scroll up and I'm going to take a look and I'm going to find my serial interfaces. Okay, so let's see, S00, that looks clean. There's nothing there. Okay, and then let's see. I need to look at S01. Why don't I see S01? Access list. Run. Okay, so let's see. Interface S001, IP access group 99N. Well, I think that's probably my problem, right? Because if we go back and we think about this, so what it's telling me is that I've got an access control list right here. So that's where my filter is, right? That's where my filter is. So now what happens is I'm sending a packet, right? And then it goes this way. Oh, and it's going to hit the gatekeeper. The gatekeeper is going to check its list and it's going to say, we don't accept any library traffic here, right? However, if the library traffic is so inclined and it's smart, right, or it's getting load balanced, it goes here. Now it hits this interface, but does it encounter a filter? It does not encounter a filter. Well, then it hits the G01 sub interfaces, right? Because look, we have sub interfaces. So on its way out, it's going to get looked at by G01.10, but there's no filter on G01.10. And then also G01.20, that gatekeeper is going to look at it. There's no filter there, right? G01.50 is going to look at it and there's no filter there. So now we know why the packet is getting through sometimes and not getting through other times. So next, what we have to do is we have to fix it. Now, there's a bunch of different ways we could fix this, right? But there's a best way. So I'm going to show you an example, or I'm going to tell you an example of like a wrong way, or, you know, again, it would work, but it wouldn't be the most effective way. What I could do is I could actually go and put a filter on S000. Okay, so now it wouldn't matter which way the packet goes, it will get filtered. Again, that's kind of an inefficient use of access control lists because I have to write two of them instead of just writing one closest to the destination. Okay, so where should I be putting this access control list? What interface? So we agree if we're doing a standard access control list, we agree it's going to be as close to the destination. So we're going to stick with our tech building, right? But where would I be putting this filter? Yeah, right. Well, we'd have to put a permit any. So Aaron asked if we also added it to the S00, would it stop all other traffic? It would. We'd have to add the permit any on there. So again, we'd have to put it on, we'd have to leave it on the S001. We'd have to add it to the S00 and put a permit any. Again, inefficient use, but it could be done. Okay, so where we want to put this is we want to put this on the sub interface, right? We want to put this on the sub interface of G01.20, right? We want to put it on the sub interface. Also, when does that packet need to get looked at? As it's coming, like as it's going like this and it's right, or as it's going in. So which way do we need it to be looked at? Right, we need it to be looked at as it's leaving the router, because the gatekeeper that's going to be doing the work is this gatekeeper, the G01.20, right? So the packet's in the router, it's getting ready to go, the packet wants to go here to sales, but instead, as it's getting ready to leave the router stops it. The interface says, wait a minute, I got to check and make sure you're okay to get through. And it sees that it's not. So it drops it. It doesn't let it go through. All right, so let's go ahead and fix this. What do I need to do? What do I need to do first? And notice we're using a numbered access control list, right? Okay, so I think that's a really good start. We can start by deleting it off of the interface. So interface S001, right? So what's the command? no IP access group 99 in. So we took it off. Okay, so do show interface S001. Let's just see. Okay, looks good. Just want to make sure it came off of there. Okay, so what do I do next? Okay, so I'm going to go to interface. So interface G01.20. And place IP access group 99 out. Okay. And is that it? Yeah. So there would be one more best practice. Did we have to deny any on here? I didn't see it. Show. Let's see. Yeah, so I probably would have done the deny any in here too, but it didn't need it for the counter. And why would I do the deny any? Yep, the implicit deny, so that I can see it, I can see the counters, right? So I can see the counters. Okay, let's try a ping test. So let's see, we're going to try ping. Let's see, what is this IP address? 81.5. Okay, that's good. I didn't want that one to ping, but I also want to make sure I can still get to other networks, right? So let me make sure I can still get to this network, 80.5. Okay, I can. Perfect. All right. Now, can PC2, the sales, can it get to the library? So why doesn't it work? Why doesn't it work? Well, it's really because if you think about it, we have the filter right here. Okay, so again, let's just think about the way that this packet is going. If I'm pinging, okay, I'm going to be able to go out my interface without a problem. And I can probably even get all the way to the library. But then the library is going to reply, and the reply gets blocked. Okay, the reply gets blocked. Okay, any questions? Oh, I was going to say one more thing about that. So another way we could have fixed this is we could have taken it off. We could have taken off the standard altogether. And I could have come over here. Let's see, let me share my screen. I could have taken the access control, the standard access control list off from here, and I could have put an extended access control list here where I filter based on the destination and the source. So that was just another way we could do it. Again, one of the things that make access control lists hard is there's a lot of different ways that you can write these. So you just have to, put your thinking cap on and think about which one would be the best way. Okay, everyone get your notes out because we're going to be talking about network address translations, NAT. NAT. It's my chat box. Okay, so what do these three addresses have in common? What do these three addresses have in common? Actually, the /12 is not classful. If that were a /16, it would be classful. Right, you're on the right track though. Anybody? Yeah, they're all private addresses. 172.16.20.7, 10.10.10.10, 192.168. They're all private addresses, right? They're all private addresses. So we know that private addresses do not travel the public network, right? They cannot get onto a WAN link. They need NAT in order to cross the public network because private addresses never leave our own network. So at your house, you have a private network. So if you're trying to go, say, Google something, or you're trying to go onto Bing, your private address doesn't make the request for the information. It actually sends the request to your router, and then your router hands it off to a public address. Well, that handoff or that mapping is network address translations, okay? It's network address translations because our private addresses can never leave our local area network. So we've learned about a lot of different products that are working on our routers, our home routers even. We've got DHCP working on our home routers. We have DNS working on our home routers. Now we know we have NAT working on our home routers, okay? Same could be true out in the industry, right? Wherever you, like at GCC, we have a 10 network. So we have to have a router that does network address translations, or else we would never be able to get onto Netacad or get onto Canvas, okay? Let's see. So if you've noticed our labs, right, our router network at GCC is the 172 network, 172.16, and then depending upon what rack you're on. And then probably in your house, you have a 192, and at school, we have a 10. Okay. Why do we need NAT? Why do we need NAT? Yeah, but why do I need to translate private addresses to public addresses? Yes, it's because we're pretty much out of IPv4 addresses. Yep, yeah, it's to save addresses. So what we've done is we've reserved a few IP addresses for private addresses. We've set some aside for public addresses, and that allows us to save the IPv4 address. Now, I think it's important for you to know that the network private addresses are described by RFC 1918, okay? And that's like the standards code. The reason I think you might need to know that is because it has been on the CCNA exams. So it's one of those RFC codes that I think is a good idea to remember. So make sure you write that down. So we know that private addresses aren't routed over the internet. They need to be translated. So we have to use NAT. NAT, NAT, NAT. Primary reason, conserve addresses. NAT allows the network to use private addresses. Now, here's the other important concept about NAT, and that is where you would normally implement NAT, okay? It's easy to know where we implement NAT at our house because we only usually have one router. So NAT gets implemented on our router. Well, in an industry environment where you might be running multiple routers within your network, you would typically want to run NAT on the edge router or the border router. So that's the router that is in between your private network and your ISP. Again, if you could think about it just like our home network, right? Our router is between my private local area network and the ISPs. So that's called a border router or an edge router, okay? So in this example, here's all of our private addressing. And then notice over here is I'm going to be connecting up to my ISP. So that's my edge router or my border router, and I'm going to configure NAT right there. Okay. A NAT-enabled router can be configured with a public IPv4 address, and then it will also have private addressing on it, okay? Let's see, to be used in the, yep. All right, so we got that. One exit point. So this is called a stub network. I've just got one exit point to the internet. A stub network is when I just have one connection to the internet, right? I don't have multiple connections to an internet. Advantages and disadvantages. Okay, the advantages are the ones we've already talked about. It reserves IPv4 addresses. It allows us to create really big and small networks and do VLSM, right? It gives us some flexibility when it comes to that. It does provide a tiny bit of security, but very little. Here's something I want you to think about as it relates to NAT. NAT is not an implementation of security. It just happens to give us a little bit of security because our private addresses more or less hide behind a public address, okay? But it's not a security feature. It's not a security feature. It provides consistency for internal addressing. Well, that's because the ISP can say, okay, here's your 192.168.0.0/20. And then me as the network administrator, I could go do VLSM and cut that up into as many networks as I want. So I can streamline my addressing, okay? With IPv6 or with public addressing, I really can't do that. A disadvantage. Because I have to run NAT, there's a little bit of degradation because when it hits the NAT router, it's got to translate my private address to a public address. Well, that takes some resources and just, again, minuscule seconds, but it still takes a little bit of time. And that along the same line, end-to-end functionality is degraded. That's just because it's having to kind of do a baton toss. I like to think of NAT like a relay race. So my home computer is on a private IP address. I want to get out to Google, right? So my packet goes up to its home router. and it like does a handoff. Well, then the public address takes the baton and it goes and does the work. Okay, so we're losing a little bit of end-to-end functionality there, okay? And that's the same thing with the IP traceability. I can't trace it because one public IP address translates to a random private IP address. Tunneling is more complicated, and we'll talk about tunneling in a couple of slides. And initiating TCP connections can be disrupted. Okay, what is significant about a TCP connection? Think about a TCP connection. And what is the method that TCP uses that could explain this? Right. Yes, exactly right. Yes, yes, yes. So TCP has to do a three-way handshake, and it has to maintain a session. Well, TCP just can't function very well with network address translations. So it can't do a synchronization, right? Remember, we want to say, oh, I need to make a session, so I'm going to sync up to you. And then the destination says, oh, well, I want to sync up with you. And I acknowledge that you want to sync up with me. None of that's possible with NAT. It messes everything up. Okay. All right. So we are going to do a little Kahoot here. We're going to do a little Kahoot. So we're going to be doing a Kahoot along the way. Every few slides, we'll pop in a few more questions. Okay. Well, that's awfully easy. NAT. Whoa, what happened there? A border router, right? Also known as a what router? A border router or an edge router. A stub network, okay? A stub, let's just look at that again. So a stub network, let's see. So this is referring to a stub network. That's when you only have one exit point, but that doesn't necessarily mean you've got a border or an edge router. So they're different, okay? They are different. Okay, what number was that? Is that number 3, 2? Oh, we have one more to do. Okay, 3. There we go. Degradation, right? Degradation. NAT can perform degradation, right? Performance is degraded. We have end-to-end functionality is degraded. It's degraded, okay? All right, so we're going to go and we're going to keep moving through our PowerPoint here. We did Kahoot 1 through 3. Okay, personally, what I find the most difficult about NAT is its terminology, okay? Basically, conceptually, NAT is fairly simple to understand. I have private IP addressing on my LANs. The private IP addresses can't get out over a WAN, so the public addressing does the job. Well, for some reason, Cisco needed to come up with all of these fancy terms. These terms are pretty much only used by Cisco. In the past, they have been on the CCNA exam, 1 or 2 questions. I don't know if they're on the new CCNA exam because I haven't taken it, okay? But I'm kind of crossing my fingers that it isn't, but it could be. So we're going to go over it, okay? So again, it's just the way they describe where the packet is at any given time, or where the IP packet is at any given time, okay? So terminology, the inside network, okay, that is the set of devices using private addresses. So it's going to be anything like right here's our NAT router. Okay, so it's going to be pretty much anything here. Okay, the outside network refers to all other destination network addresses. So that's going to be anything out here. Okay. Now, the other thing that's kind of interesting to think about is that NAT terminology is always applied from the perspective of the device with the translated address, okay? So in this case, if it's this PC, that's the PC that's getting a translated address. It starts out with a private address, and it gets translated to a public address, okay? Let's see if this is a real video. Cannot, oh, okay. So let's see here. And usually it's going to be from the perspective of the NAT router. So you know how when we talk about interfaces, right? We kind of think of ourselves as the router, and then like my arm is an interface, my other arm is an interface. That helps a little bit when we're talking about NAT too. I usually always kind of think about, okay, if I'm standing in the router, right? Where am I looking inside to the inside network? Am I looking to the outside? Is someone from the outside looking in? So I kind of think about the visual perspective of where the packet is going, okay? So I just think about that visual perspective. Okay, so again, we're going to keep breaking these addresses down. So an inside address of the device, which is being translated by NAT from the perspective of the NAT router. So again, just imagine you're standing right here. Well, this private address is the one that needs to get translated. So that's the inside address, okay? Now the outside address of the destination device from the perspective of the NAT router. So this is my destination, my server over here, okay? My server is the destination. And if I'm standing right here, right, I'm looking at it, okay? And then they mix these, okay? So then we're gonna mash these up. A local address, any address that appears on the inside of the network from the perspective of the NAT router. And again, if you think of perspective as kind of where you're seeing, what you're imagining, it's not necessarily where it physically is. And then a global address, any address that appears on the outside of the network. So from the perspective of the NAT router. So pretty much anytime we're out here, we're going to have a global. Okay, we're either going to have a global or an outside address. Okay. NAT terminology fast. Let's see if this video works, because this was a good video.
Hey guys, Austin here.
So we're going to look at, can you hear that?
Installs. What's unique about this install is it's actually running the pool completely independent of the
Can you hear that?
Covering all of the pool equipment.
Okay.
By this little mini solar system.
Today we will be learning about inside and outside local and global IP addresses as used with the network address translation. Let's first break down the words. Local refers to the IP address of a device inside of a network. Global refers to the IP address as visible on the internet. Inside can be thought of as inside of your control. Outside are things that are outside of your control. Take a look at the following network and let's start labeling things. First, let's start off with the easy stuff. What's inside your control and what's outside of your control. Now let's look at the local and global IP addresses. Inside of your network, your local computer most likely has an IP address within a private IP range. This is your inside local. Your router is assigned an IP address by your ISP in a routable IP range. This is your inside global. Outside of your control, the company you are trying to access is also assigned an IP address in the routable IP range. This is your outside global. Now, the last one was a little tricky. You might expect it to be a private IP address since it is local, but this is wrong. With this terminology, we are dealing with everything as seen from your inside network. Since you rarely see the local IP address that an external company sets for its server, the outside local will almost always be the same IP address as the outside global.
Wow. So I think, did I give you guys,
welcome.
did I give you guys that, this little tutorial in Canvas? Because that one, it's so fast, right? But I really like the way he says for inside, it's things that are inside your control. Outside, it's outside of our control. I think that's another really good way to think about it. If I didn't add that, I will add that to our Canvas shell. Okay. So location, where is the address relative to the NAT router, right? So it's inside. And again, let's think about what's in our control, right? It's in our control. Now I could have an inside local or I could have an inside global. An inside local is going to be a private address. An inside global is going to be a public address. Okay. An outside local, that means I'm inside my network, but I see it as a public address. And then outside just means I'm outside and it's a public address. Global is almost always going to reference a public address. Okay. Again, this whole perspective from where is the address being observed? Am I locally looking at it? Or is somebody on the outside network looking at it? Okay. Again, these things are just kind of tough. Okay. So we're going to break it down again. Inside local. So inside, I have control of it because I'm the network administrator, so I can control that. The address of the inside host as seen from inside the network. So it's me. I'm the network administrator. I can control the address and I can see it. It's a private address. Inside global. So the address of the inside host as seen from the perspective of the globe outside. So it's going to be the public address on my router, but I do have control over it because I'm the one who still would be setting the IP address. Okay. It's still on my router. So even though it's a public address global, it's in my control. It's in my control. Okay. Outside local. The address of the outside host as seen from the perspective of inside. So in other words, it's me over here and I'm trying to get to this server. Well, I see the server address as 38.13.64.1, right? I'm inside my network. I'm local to my own network, but I'm looking outside of myself. And I don't have control over this server address. So it's outside of me. I can't change it, but I can see it. I can see it. Okay. And the outside global, the address of the outside host as seen from the globe. So in other words, if I was over here, if I'm just another random person, I'm outside the network and I see the public address. Okay. So these, you just have to practice. You just have to practice. Inside local. Okay. The inside local address, if it needs to go ride the internet, it always has to be translated to a public address. Always. It can't get out. Okay. So the inside local is always going to get translated. Okay. It's always going to get translated to a public address. Okay. And again, that would be the inside global because I have control over it. I'm going to take my private address. I'm going to translate it to the public address that the ISP gave me, but I have control over that. Okay. I have control over that. So in this scenario, I'm the network administrator, so I have control over all of this. Okay, so what I'm going to do is I'm going to add network address translations to this router, and I'm going to make sure that I match up my private address to the public address that I have control over, 63.45.23.5. That way, whenever I want to go to the internet, that public address does the work for me. It does the driving, okay? The outside local will be the destination address. So this is where I'm trying to go. I'm trying to get to the server. And the outside global will be the source address as seen by everybody else. So again, that's this guy over here. Okay, I'm going to just hold for a minute and let you guys write some stuff down. All right, so let's see if we can identify some of these terms. So number 192.168.51.5, what would it be? Everybody go ahead and answer. I want to see everybody put an answer in the chat box. Right, Luis, half right, Aaron, half right, Servando. Well, PC1 is a private IP address, so what is the NAT term for it? Damien, you got an answer? Well, we don't use the word private address, so it is a private address, but that's not the NAT term to describe it. Right. Okay, so first of all, this is flipped from what we were just looking at, okay? So here's the public address, the web server. Here's the private addressing. So do I have control as the network administrator of the private addressing? I do. So if you notice here, I'm going to have control over all of this. So this is inside, okay, and it's a private address. So this is an inside local. This is an inside local, okay? Inside local. Okay, now number 2, I want you to look at this. So we're pointing at this interface right here. Now notice here's a private address. That's this interface. That's my default gateway. Now 198.51.100.2, is that a private address or is that a public address? It's a private address, right? 198 is a public address. 192 is a private. So now it's do I have control over this interface right here? Do I have control over it? I do. I do. So it's inside my control and it is a public address. So what's the NAT terminology? And some of you got it already. Yeah, it's inside global, right? Because it's in my control, so it's inside my purview, but it is a public address, so that makes it global. It's globally routable. It's a globally routable address, okay? All right, now this starts to get a little bit more difficult. Number 3. Okay, so first of all, the easy part. Am I inside or outside? Inside or outside? So here's the internet service provider, ISP. Yeah, so this is outside, right? This is outside. Now, what I'm not sure if they're outside. Okay, I think I know what this one is. So I'm outside, and it's basically where, I don't know. So it's outside, but I don't know if it's global or local because I'm not sure who's looking at it. Okay, so if I'm sending it there, I think that this is going to be outside local. I think this one's going to be outside local because this is where I'm trying to get to. But it could be outside global. Let's see. Outside global? Okay. Yep, outside global. Good one, Damien. Good one. So outside global, outside global. So then I think this one's going to be. Nope, this one. Okay. I know why. We can't even see that address. So we're not sending it there. That's why it's outside global. That's just on its public, that's on its way to its public network. But look, from PC1's perspective, I'm trying to get to this web server. So I know this address. So that's why this one's outside local, because I'm trying to send something to the web server. I'm trying to get something from the web server. So I know what that public address is. That's why that one's outside local. It's outside of my ability to control it, but I know what the address is. So it's outside local. Yeah, it's a little tricky, Let's see. This is just more of the same, explaining how these relate to the source address or the destination address. It's just another way to look at this terminology. What's the source address or the destination address? Okay. Okay, let's try Kahoot 4 through 7. So you're going to go back to your Kahoot. I'll give you a minute. Ready? 4 through 7. So yeah, the inside address is what is being what's being translated, the inside address. The local address, remember, we can see even local on the outside of our network. It's just that it would be a global. So it's inside address. Inside is always private. They always need to be translated. Local doesn't always mean it's private. Yeah, so remember, inside is where the address is relative. So here's the NAT router. Is it inside my control or is it outside of my control? Inside and outside refer to physical location. Local and global is perspective. It's perspective, okay? Inside global. So here's my NAT router, here's my private address, and then here's my public address. So this private address always has to get translated to the inside global address. So it's inside my control, and it was publicly assigned by the ISP. Okay, so let's look at this number blue, okay? The address of the outside host, that would be outside local. So again, I'm at my computer, okay? And I have a private address. I'm inside a LAN. I'm inside a LAN, but I want to get to eBay. And eBay has a public address. Okay, so that address is outside of my control, but I know what that website is or what that address is. Okay, and that's because even though I'm inside of my own private network, I still know what that public network is. Okay, so this one is correct because outside global, it's out of my control. Okay, and it's accessible from the outside by anybody, outside global. The address of the inside host is seen from the outside. This would be inside global. Inside global. Yeah, you got to play with these. They're not easy. Oops, wait a second. Allows external. Okay, here, I'm going to give you the address. I'm going to give you this. Oh, am I going to give you this? Allows external users to access internal server on, I don't know, oh, static NAT. Static NAT. Did I give you the right answer? I did, right? I had to think about it. Okay, so let's go back to the PowerPoint. Okay. I'm praying that they've taken these terms off of the CCNA. They give me a problem too, trust me. What I do is I always just go and watch all those videos and I build packet tracers and I watch packet tracers, which we're going to do a little bit today, okay, if we have time. How does NAT work? The private internal IP address gets translated to the public IP address. Think of that as the baton handoff, okay? It's the handoff. Now, we know that these routers, they keep track of all kinds of tables, right? And they keep track of DHCP information. They have ARP tables. They've got static route tables. They have dynamic route tables, all kinds of tables. Well, here's another table that the router has. It has a NAT table, okay? A network address translations. That's how it keeps track. So here we go. This private address needs to get out to the public web, okay? So they send the packet. They send the packet. Now here's our NAT router. So what the NAT router does is it's like, okay, so you need to get out onto the public network? Yeah, I do. So I more or less park my private IP address in the table, and then I match up whatever the public address is that's going to do the work. So in this case, the public address that's going to physically do the work and go out over the WAN is the 209.165.200.226. Now, where is that? That's this address, which I have control over. I have control over it. It's inside my network, but it's a public address. So it's going to do all of the work. Okay, so this is what's going to be inside of my NAT router. All right, and then it's going to go ahead and send it out, and it's going to hit the web server, and then it's going to respond back. Okay, so the web server gets the request. Now it's going to respond back. It's going to hit the table, and it's going to say, oh, well, 209.165.200.226 was working for 192.168.10.10. So now it hands off the information to the private address, and now it carries it down to the PC. So if you think of it like a handoff, okay, it's doing a handoff. How NAT works. Second, the translated public address, okay, the translated public address is used by the server to send the requested information to the device that actually has a private address. So again, that's that return trip. Okay, that's the return trip. Number 3, the NAT-enabled router consults the routing table to see what the private address requested data was, and then it gives it back to the PC. Okay, it gives it to the PC. All right, there's 3 types of NAT. 3 types of NAT. Static NAT, and that does a 1-to-1 mapping. So one private address matches up to one public address. 1-to-1, static, 1-to-1. Number 2 is dynamic NAT. So with dynamic NAT, I'm going to have a pool of public addresses. So I might have 5 or 6 public addresses. If I have a really big company, I might have 200 public addresses, who knows? And they get assigned on a first come, first served basis. Okay. So if I have 20 public addresses and I have 50 private addresses, so 50 employees, how many employees can go out onto the web at once? I have 50 employees and I have 20 public addresses. How many can go out onto the web at once? $50 employees. I have 20 public addresses. How many of my employees can go out and go onto a web server at one time? Okay, so look what this says. Uses a pool of public addresses. So I have 20 addresses in my pool, and it will assign the public addresses on a first come, first served basis. 50 employees, 20 public addresses. How many of my employees can go out onto the internet at once? Right, Damien? Okay, I've only got one guess so far. I have two guesses, one correct one, right, Servando? 50 employees, 20 public addresses, first come, first serve. How many employees can get out onto the internet at once? No, they can't all get out. So if I have 50 private addresses for 50 employees, can private addresses go out on the internet? I've got 50 of them. Can private addresses go out on the internet? And then I have 20 public addresses. Okay, I have 20 public addresses. Can public addresses go out on the internet? Yep. So that means that at any one time, if I'm using dynamic NAT, only 20 employees can get on the internet at once. Okay? Only 20 can get on the internet at once. If the 21st employee tried to get out on the internet, what would happen? Yeah, it would just be dropped. It would be denied. It cannot get out on the internet because only public addresses can get on the internet. Now, all of these employees can still talk to each other on their own LAN because they don't need to go to the internet. But another one cannot go on the internet until one of them hangs up. Okay? Till one of them hangs up. So that's how dynamic NAT works. I would pay the ISP for public addresses. Okay? And I would say, well, maybe I have 50 employees. Usually they don't need to go on the internet. So I think I could probably handle 10 public addresses. And I think that'll work. Okay. Next, we have PAT. PAT. PAT is called Port Address Translation. Port Address Translation. Okay. Now, this more or less fixes the dynamic NAT problem. Okay. Because what I do is I assign port numbers, just randomly selected port numbers, so that with one IP address, one public IP address, I can map lots of different private addresses to one, okay, to one public address. I just use ports. Okay, I would just use ports, and I'll show you an example of that. Okay, so here is a one-to-one matchup. I have one private address, I have one public address. I have one private address, I have one public address. I have one private address, I have one public address. Okay, now here's dynamic NAT. Okay, I have an inside private local address, and then there's this whole pool of available addresses. Okay, so as long as I have an available public address, any of my private addresses can get out. Any of them can get out. The minute all of these are used, nobody else gets out. Okay, now look at this. Okay, everyone look at this. Now what I can do is with PAT, Port Address Translations, I can start to use port numbers, okay? I can use port numbers. So here's my 192.168.10.10, port number 155. So I just assigned the public address with my port number. So see that right there, 155? Now, if I want to send something else, okay, from a different IP on my same network, so this one did one thing. Now this one's going to, look at this. I can use the exact same public address, but I just give it a different port number. So now this public address can do the work of 100 public addresses because it uses port numbers. It doesn't need to have its own public address. As long as I have one public address, I can use port numbers, okay? That is how our service works at home, okay? That's how our service works at home. I might have lots of different devices at home with private addresses. My TV has its own address, my computer has its own address, my laptop has its own address, my cell phone has its own address, but I'm not paying the ISP for 20 public addresses. I have one public address. So when I have, say, 4 or 5 private addresses trying to get out over the internet at the same time, they just get a port number and they use the same public address. They use the same public address, okay? All right, so a static map is a one-to-one, one-to-one. The other thing, in most networks, you're going to use a combination of all of these. Okay, you're going to use a combination of all of these. At GCC, we have some of our servers statically mapped, okay, a one-to-one mapping. And then for others, we might have dynamic. But for the bulk of our addresses at GCC, we use PAT, Port Address Translations, okay? All right. So it's pretty easy to do a static NAT, okay? Now, when you put a public address with a private address, that's called mapping. You're mapping it, okay? You're mapping it. So let's look at the configuration. So here is our NAT router, R2. Okay. So we're simply going to do IP NAT inside source, static, because I'm doing a static map, one-to-one. Here's my private address, there's my public address. Okay. Like access control lists, we do have to tell the interfaces what their jobs are. A different function than an access control list, but we have to tell the interfaces what their job is. And that doesn't matter what kind of NAT we're using, static NAT, dynamic NAT, or PAT, okay? We have to tell the router's interfaces what its job is, okay? So let's take a look here. So here's our inside network. So S00 is inside. It's inside. Okay, so you just tell it S00 IP NAT inside. And then we also have to tell S010 what its job is. Well, it's on the outside of the network. So we have IP NAT outside. Okay. That's how it knows how to do the mapping. Okay. Static NAT is the easiest NAT to set up. I mean, none of them are that hard, but this is definitely the easiest. Regardless of what NAT you have, what do you think might be a common mistake that would mess up your whole network? What could be a common mistake that can mess up your whole network? Yep, that's right, Aaron. A very common mistake is just flip-flopping these. So if I said that the inside interface is the outside, or the outside interface is the inside, your network doesn't work at all because nothing gets out of it. Nothing gets into it. So you got to be super careful to make sure that you're putting your inside interface on the local side, the inside, and the outside on the outside. And that doesn't matter what kind of NAT you're using, okay? Okay, next we have dynamic NAT. We have dynamic NAT. With dynamic NAT, remember we have a whole bunch of private addresses, and then we just have a pool of public addresses. So I have to pay the ISP for that. Okay, so I'm going to set up a pool. Let's say I buy 5 or 6 public addresses. So I create a pool of the public addresses. And remember, those get assigned on a first come, first served basis. So when an inside device gets to the router on its inside interface, and it's like, hey, I want to pass the baton. I need to get something off of a web server, an external web server. So what the router does is it checks to see if it has any public addresses available, and then it maps it to that private address to whatever the public pool address is, okay? There always has to be enough addresses in order to do the matchup, okay? So here's like our private address, 192.168.10.12. Hey, I want to go swimming in the public pool. Okay, so it's going to match up. Oops. It's going to go in and it's going to be able to grab one of these guys so that it can get out onto the public network. Okay, onto the public network. So here's an example, right? Here's 1, 2, 3, 4. Here's my 5 addresses in my public pool. So as long as these are still open, any number can get in there. What if the number 6 wants to get out? What happens to number 6 if they're all in use? And now number 6 wants to get out. Yep, he can't get out. So what type of NAT could I use that would fix this problem? I could use PAT, right? I could use PAT. Okay, so let's look at the steps for configuring dynamic NAT. So configuring dynamic NAT and configuring PAT are almost identical. So we're going to walk through these, and then when we do PAT, I'll show you the one tiny little difference. The one tiny little difference. All right. So the first thing we need to do is we need to define our pool of public addresses. Okay, so what other protocol did we have to set a pool up in? There's another protocol we learned about where we had to set up a pool. Yeah, DHCP. So it's kind of like that. If you remember, we did IP, DHCP, pool, and we had to set up a pool name. Same thing. We're going to do IP NAT pool, okay? And then we need to give it a name. We need to name it. Now, in this example, they used NAT pool 1. NAT pool 1. Now, the NAT pool 1 is a range of addresses. So I want you to look here. This is 209.165.200.226 space 209.165.200.240. So it's all of those addresses, 226, 227, 228, 229, 230, 231, 232, 233, 234, all the way up to 240. Okay, so it's quite a bit of public addresses. So this Network administrator is paying for all those public addresses. And then we got to tell it what net mask. What is its subnet mask? Okay, so that's nice and easy. We just have to create the pool of public addresses, okay? Have to create the pool of public addresses. Then here's the next thing we have to do. We have to configure an access control list so that the pool knows what networks, what private networks are allowed to use the pool, okay? So like if you think even about a public swimming pool, right? You want to know who's allowed to use the public swimming pool, okay? Or maybe the apartment pool. Okay, you don't want just anybody using that. You have to maybe be a member or you have to live there, okay? So that's what the access control list does. So we set up a pool, we set up an access control list, okay? Now, can you see how everything we've been learning is coming all together again? We had to learn about private addresses and public addresses. We had to learn about WANs. We had to learn about access control lists. Now we're bringing it all together. So I've created a pool. I've determined who can go swimming in that pool. Okay, next I have to marry the pool and the access control list so that they know they're working together. Okay, so IP NAT inside source list 1, that matches up to the access list. So I'm saying this list 1 is allowed to go into the pool called NAT pool. Okay, build the pool, tell the pool who's allowed to go into it, then match them up so that they can work together. Okay. And then lastly, we still have to tell the router which interfaces it's inside the network, which interface is on the outside of the network. Okay. So here we've got our IP NAT inside and our IP NAT outside. What could you do if you don't remember all these commands? What could we use? The question mark. So if you type IP space question mark, it'll just walk you through these. It will walk you through these, okay? Now notice we used a numbered access control list. You could use a named access control list. I find it a little bit easier when I'm doing NAT to just use a standard numbered access control list. And the reason I like a numbered access control list for NAT is because I've already got a pool name. I don't want to have to also contend with an access control list name. Again, you can do it. I just find it a little bit easier to do a standard numbered, and then create my pool. Okay. All right, did everybody get those commands down? Okay. Okay. So the ACL tells us who can swim in the pool, right? Okay, so now let's just talk about the third kind of NAT, the most common kind of NAT, okay? And usually you might use them all at the same time. So here's the difference. With PAT, port address translations, what we do is we overload one public address with lots of private addresses. Okay, we overload one public address with lots of private addresses. So notice here, it will map to multiple private IPv4 addresses to one single public address. PAT will use the source port and the source IP address pair to keep track of what traffic belongs to what client. Okay, so PAT is able to translate protocols that do not use port numbers. So this comes in handy for things like ICMP, because there is actually a port number associated with ping, but it's not used. It's not commonly set up. Again, let's just take a look. So here's my private addresses, 192.168.10.10, 192.168.10.11. Right here is my public address, so my inside global address. So this is the one that needs to be used to get out onto the internet. What I'm going to do now is I'm going to take this 192 and I'm going to assign it a dynamic port number. The computer just assigns that dynamic port number, like through I think the NIC card does it. And then now this global address is going to keep track just using that port number. And think about it, this is the table. So it's storing this information in the table. Now our 10.11, it gets a differently randomly generated port number. And now it's using the exact same public address, but it's got the different port number. Okay, it's got the different port number. Now it's got to use the port numbers also for the destination. So do you guys remember when we did the TCP and UDP worksheet? We did the source and destination port number. That's along the same lines, okay? It's functioning in a similar way. All right. Here's the one tiny little difference between dynamic NAT and PAT. The only difference is a keyword, okay? The pool, I still have to create a pool. Now, in this case, we're using still several different public addresses, but I might only have one, okay? Now, if I only have one, I wouldn't necessarily have a pool, but so I've got a little group of public addresses. I create my access list. So I'm telling the pool who can go swimming. Now I'm marrying my access control list to my pool. And then look here, I use this keyword overload. So I'm telling it, hey, listen, go ahead and overload the public address with private addresses. Overload it. You can give it 50. Overload it. Overload it. Okay. Everything else is the same. And that is the way our home routers work. They use overload. They use overload so that all my devices in my house can get out onto the internet by overloading my inside global address. Okay, my inside global address. The only difference is the overload. Everybody got that? Okay. All right, we're going to do Kahoot 8 through 15. How many types of NAT are there? Everyone should get this one right. show IP NAT translations shows us the translations between the private and the public. Traffic is dropped. Source. A standard access control list can only deny or permit based on the source. That's why we use a standard access control list for NAT. Define a pool of public addresses. You don't define a pool of private addresses. What do you do with the private addresses? What do you do with the private IP addresses? So public, we define a pool. Public, we do what? A private, we do what? Now you got to do something. DHCP doesn't have anything to do with NAT. I mean, other than it's an IP address. So the first step is to define a pool of public IP addresses. What's the second step? Let's see. Configure the standard access control list for what? You're absolutely right. The second step is you configure the access control list for what? What network? Okay, so the source network and right, Damien. You configure an access control list for the private addressing network, the private addressing. So define a pool. This needs to be in your notes. Define a pool of public addresses. Set an access control list for the private addresses. Marry the pool and the access control lists. Set the interfaces. So we have two more. So what parameter defines what internal addresses are translated by NAT? Okay, so an internal address is just a what? What kind of address is an internal address? Is it private or public? It's private. Okay, so again, we just went through those steps. Number one, define a pool of public addresses. Number two, an access control list will define what internal addresses. In other words, an access control list will define what private addresses can be translated by NAT. So I could have two separate networks, and one of them I don't let go out using NAT. Okay. Number 3, I marry them so they know that they're working together. Yep. So if I use overload, that's saying go ahead and overload my public addresses with private addresses. Okay. Let me see. Okay. We're going to skip this because we don't cover this anymore. So here's just a couple of show commands that are super handy for analyzing and verifying NAT. Okay, show IP NAT translations. Now, if you use the word verbose, verbose means a lot. It'll just give you a lot more information. Okay. You may want to clear your NAT table out and just clear out all the matches. So that's what clear IP NAT translations will do. And then you would clear out the statistics, the counters. Okay. So just some helpful commands. Now, you might be thinking to yourself, why would I need NAT for IPv6? Because IPv6, the whole reason we got IPv6 is because IPv4 isn't robust enough, right? We don't have enough of them. So why do I need IPv6 and NAT to work together? Well, the reason is because we actually use NAT to dual stack or make it possible for both networks to work together. If you have an IPv4 and you have an IPv6 network, or if you're trying to communicate from an IPv4 to an IPv6 network, that can be really complicated. And so you need NAT in order to do that. So there's 3 different options for having an IPv4 and an IPv6 network be able to work together. One is dual stacking. You on one network, you run IPv4 and IPv6. We've done that in our labs before. We've set up both. Okay. Another way is something called tunneling. Okay. Now, tunneling is not the easiest thing to do. It's basically when I take the IPv6 information and I encapsulate it inside of an IPv4 packet so that it can move across an IPv4 network. Okay. Well, then there's something else I can do, and that is called NAT64. That does a NAT translation. It allows an IPv4 network to communicate to an IPv6 network and vice versa. Okay. It's really designed as a transitioning mechanism. You don't want to leave NAT64 on your network forever, but you can until you get transitioned over to an IPv6 if you're communicating with lots of other IPv6 networks. And NAT64 is the preferred way to mash up your IPv4 and IPv6 networks, NAT64, because it's less resource intensive, okay? Now you will see this on the CCNA. I can almost guarantee it. You will see it on the CCNA. NAT64, you'll want to know. Okay, let's see. NAT for IPv6 is used in a much different way. Let's see. NAT for IPv6 should not be used as a long-term strategy, but as a temporary mechanism to assist you in the migration of IPv4 to IPv6. Okay, and we're coming to the end here. I just want to remind you of this type of IPv6 address because it might be reminiscent of a private address on IPv4, and that is something called a unique local address. So you might remember we have link local addresses for IPv6, and we have something called a unique local address. Well, a unique local address is similar to a private address in that it doesn't leave the LAN. It doesn't leave the local area network. It only communicates within its own site or its own LAN. Now, those IPv6 addresses are always going to start with FC00. Okay, FC0, or just actually, they're always going to start with FC. It might be FC57, but it's always going to start with FC. Okay. So now this will allow sites to be combined or privately interconnected without creating any address conflicts or requiring renumber of interfaces that use these prefixes. It's independent of any ISP, so as a network administrator, I can just set up whatever I want because it never leaves my local area network. They're not routable on the internet. And the way they know they're not routable is because of that FC. They know it because of the FC, okay? So it's a good idea to just review the different types of IPv6 addresses as it relates to NAT64 and the mechanism to convert an IPv4 to an IPv6 network. Unique local. So this is similar to a private IPv4 address, or maybe even like in a PIPA address, right? It's closer linked to a private IPv4 address. A link local address is closer aligned within a PIPA because they're self-generated. They're self-generated. Okay, and then we're going to do the last few Kahoot questions. Okay, we're going to do the last few Kahoot questions. So what is the last step in configuring NAT? The last step. Yeah, you've got to put it on the interfaces. You have to tell the router which one of its interfaces is inside, which one of its interfaces is outside. Okay, so let's look at that. IPNAT inside source list 1. Okay, so it's telling us which access control list binds to which public pool. So this is binding access control list 1 to my pool of public addresses. Okay. Number 3, yeah, no, not defining the NAT networks because the access control list defines the NAT networks. If you look, we don't even see any networks, right? We don't even see a network address, so it can't be defining anything. Okay, what happened here? So dynamic NAT, right? That's many to many. So I have private IP addresses that can match up to public IP addresses. But you've got to have, you have to have a public address for every private address, right? So it's a many to many address mapping. Let's see, blue. can map multiple IPs to a single IP of an external interface. This would be PAT. This would be PAT. I can map multiple IPs to a single IP of an external interface. The external interface would be my NAT router's public IP address. It would be my public IP address. Okay, this is that one we just went over. We just covered this whole thing about the unique local address, right? I think you guys should have all got that one right. What address is designed to allow IPv6 communications within a local site, right? A link local address. That does the same thing, but that's not what we were talking about as it relates to the local site on this PowerPoint slide, okay? Okay, yeah, again, make sure this is in your notes. This is what we were talking about. NAT 64 is now recommended. It's not meant to be a long-term transition mechanism, but it is the preferred transition mechanism. Okay. All right. You don't need to enter your score because I'll do that. I'll enter your scores. Good job. 15 out of 20. I'd say that's pretty good, Louise. Okay, that's pretty good. Good job, everybody. Remember, the hardest part about NAT is just the terminology, right? The terminology is kind of the hardest thing. So let's just all cross our fingers. Let's just all cross our fingers and hope that they don't have that anymore on the challenge, on the CCNA. Okay, so here's what you need to do tonight. Okay, here's what we need to do tonight. The checkout activity is open. Okay, the checkout activity is open. And let's see here. And then I want you to load your notes. So load your notes and do the checkout activity. I'm going to add a little bit of time to the checkout activity. It's due at 9:15. I'll actually make it due at 9:30. I'll give you a little bit of time. Okay, I'll make it due at 9:30. Okay, so go ahead and do that and submit your notes. I'll see everybody on Wednesday. So Wednesday, we're going to start talking about Module 13, which is SDN. We're coming to the end. It only has one question? Okay, hold on. Are you sure? Oh, yeah, it looks like it has one question. Okay, what the heck? Hold on. I'll fix it. Wow, what is happening here? Okay. So refresh, like you might have to hit submit and then refresh and see what it does now. You can't submit notes. Okay, let me check on that next. Yep, I can see why. I will fix that next. Online. Uploads. Okay. You should be able to do refresh for your notes. Francisco, can you tell if the questions have updated now? Okay, good. Thank you for letting me know.